Hello guys, I am Avinash. Welcome to my YouTube channel. In this session, we are going to discuss how to find the intersection between two linked lists. Okay, coming to problem statement, here they gave us two linked lists, that is linked list A and linked list B. So from the figure, you can find that both linked lists are intersecting at one point. So that is our main agenda. Means we need to return the intersection point. Intersection point means nothing but we need to return the address of the particular node where both linked lists are intersecting. I'll try to explain this thing visually. Let's say why pink color came, I don't know. Okay, let's say this is linked list A and this is linked list B. I know these are not looking like linked list. Okay, it just we can do anything. I'm not that much good artist. Okay, let's assume some values 1 2 3 4 5 6 7 8. You can assign any random values, that's not a problem, that's not a big deal. Okay, so we need to return this node, this linked list 1 and this linked list 2. A and B are intersecting at 4. We need to return the address of 4. We don't need to return the value of 4. We need to return the address of the particular node. This is our main problem statement. I have two different approaches. First, I'll try to explain the first approach, which will take complexity of ampersand. So first we need to find the length of both linked lists. That means let's say length of A is L1, length of B is L2, and then we need to find the difference between both linked lists. Here we are making L1 minus L2 since the size of A is bigger than the B linked list. If the size of B is bigger, then we need to do L2 minus L1. That's not a big deal. Okay, then we need to do, after finding the difference, let's find out 1 2 3 4 5 6. This is 6, this size is 6, this size is 5. Okay, so what is difference? Difference is 1. So we need to assign a temporary node for both temp1, temp2. Initially they both will point at the head node, so difference is 1. So we need to move the temporary node of the biggest linked list by the difference. That means using while loop we need to move this temp node here. We need to move this temp node one step. We are moving this temporary node one step because the difference is 1. So temporary one will be here. So after doing this thing, using while loop, we need to move these two temporary nodes parallelly. Okay, while moving inside while loop, we need to make a condition, if condition. Let's say using if condition, we need to compare both values of temporary nodes. If the temporary node 1 is equal to temporary node means we need to return the particular value. Let's say in first iteration, temp1 will be here, temp2 will be here. In next iteration, temp2 will come here, temp1 will come here. So if condition will get satisfied and we will return 4. Okay, now going to implementation part. How to find size of a linked list? Let's say this is size, this is linked list. I know I am troubling you of not drawing properly, but you need to adjust. we are not having any other options. So we need to point temporary node at head. So initially we need to consider size as 0 using while loop. We need to move temporary node here. In first iteration it will come here, rest will be 1, and in second iteration it will come here, rest will be 2. In third iteration it will come here, rest will be 3, rest means size. In fourth iteration size will be 4, temporary node come here. Inside while condition we need to take temp not equal to null. So after coming here, while loop will stop executing since temp will be null. Okay, like this we can find the size. So instead of finding size for each list, we can use a method which will return us the value of the size. List node, let's say head. So what do we need to do? Initially size will be 0. I think you will get confused. Size will be 0 and we need to assume temporary node as head, and we'll start moving temporary node until end. And in each iteration we need to increase size and we need to move temporary node by 1 step forward. Finally we need to return size. This is implementation. This is exact implementation of how to find the size of a particular linked list. Implementation is done. Now consider some edge cases. What if size of linked list is 0? Then head will be automatically 0. If head equal to run means we need to return 0. So using this method we will get the size of a particular linked list. Int size 1 equal to method of head A. Head A is size 2, method of head B. Head B represents linked list B. So we need to get the difference of both lengths. Math.avs size 1 minus size 2. Okay, so what is the next step? We need to move temporary node of the largest length node by difference by n steps and represents the difference. Let's say length of linked list 1 is greater. So here we need to first we need to initialize some temporary nodes. Temp1 will be for list A. Temp2 will be for temp2 for linked list B. So using if condition we need to find which one is greater. Size 1 greater than. Here size 1 is greater than size 2 means linked list 1 is greater than linked list 2. Length of linked list 1 is greater than linked list 2. So what do we need to do here? What do we need to do here means we need to move temporary node of that linked list by n steps and represents difference. Temp1 equal to temp1 dot next. We need in each iteration we need to reduce difference value by 1 and we need to move temporary node by 1 step. So after moving we need to do this thing. Okay, let's say size of linked list 2 is greater, then what do we need to here? Same procedure. temp2 equal to temp2 dot next f minus minus. So up to now we completed 50% of the problem. Next, what do we need to do? We need to move parallelly both temporary nodes. Means we need to move both temporary nodes by one step. Remember, whenever we are using temp.next inside while loop, we need to make sure to include this condition. If you didn't include it, if you don't include this condition, it will throw an exception, null pointer exception. So what do we need to do here? We need to compare both values. Temp. Move both temporary nodes by one step. Okay. If there is no intersection, means we need to return null. Let's run. See magic. It worked. And this solution is 99.5% optimized. That means this is the most optimized solution for this problem. Okay. What will be the time complexity? Time complexity will be n plus m, and space complexity will be 1. Since we didn't initialize any arrays or any other data structures while solving this problem. That's it, guys. Thank you for your time. Bye.